Okay, this lesson is over the nets and surface area. So the last chapter we did was over two-dimensional figures. We talked about area and perimeter. Now we're talking about three-dimensional figures. So we talk about nets, we talk about surface area. So that's the area on the outside of your three-dimensional figure. Like if you were to take a box and spray paint it, how much paint you would use on the outside. And volume would be if you took that same box and filled it up with water, how much water you would need. So we're going to talk about surface area and nets today. So first definition, a net is a two-dimensional figure that can be folded to form a three-dimensional figure. So I don't know if you guys still did this, but when I was in elementary school, one of our activities is we would make a pair of dice. They would hand out a piece of paper, and you would cut it along the lines, and then you would fold it and tape it together, and it would end up being a cube. It would be a three-dimensional figure. Now, the other thing I want to make mention of is that nets aren't all the same. So, for instance, this cube could be different. I could do it differently. I could take these off, and I could put them over here, and it would still be a cube. There's several different ways you can draw these nets. I'll talk about the ways I like to do it later, but several different ways. Faces are on top and bottom of the prism. They are the ones that are not rectangles. Now, obviously, sometimes all the sides are rectangles, and then you have a little bit of freedom. But for the most part, the bases are the shapes that are not rectangles. Lateral faces are the sides of the prism. These are all rectangles if you're talking about a prism. I guess I should mention that with a base, when I say they're not rectangles, that's the base of a prism. The base of a pyramid is a little bit different. A prism is a polyhedron with two congruent and parallel faces called bases, and the other faces are lateral faces. Again, it doesn't say this specifically here, but those other lateral faces are rectangles. Also, if you want to try your hand at wrapping, this is a very good sentence to do it with once you get to the parallel part. The parallel faces called bases, and the other faces are lateral faces. It's like Eminem, move yourself to the music. The moment, the movement. I don't actually know the song, the lyrics to that song. So a figure is named by the shape of its bases. And so if you look, the bases are the parallel sides. I guess that's one of the things I could stress. The bases are the parallel sides. So for this one, it's the top and the bottom. It's a pentagon, so it's a pentagonal prism. This one, triangle, so it's a triangular prism. And this one is a trapezoid, so the trapezoidal prism. If you don't know what to put and you just put like pentagon prism for the first one or trapezoid prism for the last one, I'm okay with that. That's completely fine. Last thing, again, these are all prisms. So if you look at the other sides that aren't bases, the lateral faces are all rectangles. Lastly, we have a cylinder is a three-dimensional figure with two circle bases that are congruent and parallel. So essentially, it's kind of like a prism with circle bases. So is a cylinder a prism? The answer is no. And the main reason I would say is because the lateral faces are not, try to explain, they're curved basically, I think is the biggest thing. To be honest, though, I don't know why they don't do that. I don't know why they can't call this a circular prism. But it seems like they do that a lot with circle stuff. Kind of like the circumference instead of calling it the perimeter of a circle. So we need to name all these figures. Don't make this harder than it is. The first one, top and bottom, are pentagons. The next one, they're hinting that that is a square. It's got nine congruent sides. It's got 4 congruent angles and 4 congruent sides. Sounds a square prism. Trapezoid prism, rectangular prism, and a cylinder. Shouldn't be too bad. The next one, name the following prisms giving the nets. Now again, if you look, all these have these rectangles in them. Those are all the lateral faces. So the other ones that are not rectangles are probably your bases, are definitely going to be your bases. So the first one has a triangle prism. And I apologize if I'm going too quickly. I recorded this once already, and then I made a mistake, and I'm redoing this. And so I'm trying not to go too quickly, but I don't want to repeat myself. Anyway. Next one's a rectangle prism. Now you might think it's a square prism because these top and bottom look like squares, but they don't tell you that. They don't say they're congruent at all. They don't give you anything about the angles, and so we're assuming that it's rectangular. Next one, those top and bottoms are hexagons, so hexagonal. Next one is a normal pentagonal. We've done a couple of those, and the last one is a cylinder. I will come back to this when we talk about nets here in a second, when we talk about drawing our own. So draw a net for the figure below. So the way I think it's easiest to do it is to pick out what your bases are. And then just like they do for every single one of these, all your rectangles, all your sides, they just put in a row. And then they put your bases on top and bottom. Now again, there are several other ways to do this. So there's other ways you can do this. You might have a different answer than your partner. It all doesn't make any difference. But I think that's the easiest way. So I personally think the harder ones are ones like this, that you're starting with a rectangle because you have to kind of pick what your bases are. For my bases for this one, you can do it however you want, but I'm going to pick this as a base. And this top part over here is the base. Now the hardest part about this is making sure you label the sides as far as what the lengths are. That's going to help us a little bit later. So I'm going to first start by putting this side down. Not our bases, I do that last. So I'm starting with that first face. That first face that I drew a little bit sloppy. You don't have to use like a ruler and a straight edge and a square or right angle thing, but it does help to be a little bit clean. So that face that I just drew is 9 by 6. 9 by 6. So once we have that, now I'm going to go on to this side. Is about right here. And then this side over here. Over here. And those are both 2 by 9. So you're 2, you're 9. And then the last one, now we have the bottom, and it's exactly the opposite of the first one we did. So it's also 6 by 9. So that's all the sides. Now we're talking about the bases. Now again, a rectangular prism, you could have picked different bases. That's fine. But I go back to the first side that I started with, that green side. So this is the one that I started with. And then putting my bases onto that. So I have this base and this base. And if you look, those both are 6 by 2. That wasn't very straight, but so 6 by 2. Now again, I think it helps to actually label. So sometimes if you didn't label all these as 9, I can live with that because they all have to be 9 as long as one of them is labeled, then they all have to be rectangles. But I think it helps to label each one of them for what we're going to do a little bit later. A little bit later, we'll talk about the surface area. And so if you have all of those labeled, I think that helps. This one, cylinders are actually the easiest. All you need to do is draw a rectangle and then draw the base on top, the base on bottom. You can kind of imagine taking those two circles and bending them towards you and then wrapping that rectangle around them. So this is 8 is the height, and the diameter for both of these is 22. You don't have to label this height. They don't give that to you. If they wanted you to find it, it'd actually be a really interesting question. But it'd be the circumference of the circle since it wraps around the whole circle. But again, they don't ever ask for that. We don't need that. Just a good thing to check on. Second, but I don't have to do that one. If you want, maybe you're at lunch, I would imagine. So I don't know. But if you wanted to hit that. Sorry, I apologize. There's somebody that wanted to get into somebody else's room, and I do not have keys for it. And I would love to redo this video for a third time, but I'm not going to. So draw a net, sorry about that. Draw a net for the figure below. So now we actually do have bases. So these bases are the triangle. And again, the other one we did, you just had the option because everything is a rectangle. So I don't start with the bases. That's the last thing I do. So I'm going to start with the shape that is in front here. That's how I always like to start. And that is very clearly 5 by 10. And then I will do this side over here. Folds out to kind of the right-hand side. So that's over here. And that is 5 by 8. And then we have this side over here. It's going to be on the other side. And that is 5 by 6. And last but not least, then we have the base. Now again, I put the base on the very first front side that I started with. So I put the base here. Because I think you can make it look kind of like it looks in the picture, 6 and 8. 6 and 8. But again, you could do that differently if you wanted to. Now again, this is going to be where you have to squint your eyes a little bit. But you could also draw it over here. It would just be 10 and 8 because this side is the one that's 6. So if you want to do that, that's fine. I just think it's way easier to visualize since the front is what we put as the red over here. Then you can just kind of make it look exactly like it looked like in the picture over here. 6, 8, and then again, the 10 side is this one. So, the last 4 of these, I think 4 or 5, you are finding the name, you're doing the net, and then the surface area. Now again, the surface area is something we will talk about a lot more later. There's actually formulas where you are able to take the 7, 8, and 10, and you put that into a formula and hit enter, and then it'll give you the surface area. But for this first one, I want to show you how to do it by using the net. It takes a little bit longer, but it will also help you understand what a net is. So first off, this is obviously a rectangular prism. If I can spell that. So the net, if I were you, I'm going to call this my base and this my base. So I'm actually going to start with, this is going to be my front side. So I'm going to make that facing me. So that front side is 7 by 10. And then on either side of that, we'll have this side and this side, which is 10 by 8, which also is not drawn to scale in my picture or this picture. This is 8 and this is 7, so don't worry too much about that. But don't forget, we also have the front side, the red. We also have the bottom is the exact same. So we need the bottom side over here. So that's 7 by 10 as well. And lastly, then we need the 2 bases that I said at the very beginning, or the 2 things we called bases for this one. 7 by 8. 7 by 8. Now again, it's not drawn to scale, neither is their picture, that's fine. So, to find the surface area, we find the surface area of every single one of those sides. Or, sorry, we find the area. So, length times width, they're all rectangles. So, 7 times 10 is 70. 8 times 10 is 80. 7 times 10 is 70. 8 times 10 is 80. And we have our bases. 7 times 8 is 56. 7 times 8 is 56. So that's the area for all those. So this one is 70, 80, 70, 80, 56, and 56. Whoops. So all you need to do to find the surface area is add all those together. So 70 plus 80 plus 70 plus 80 plus 56 plus 56 is 412. Now, again, since this is area, it is meters squared. All right, let's go to the next one. This is a triangular prism. The bases are triangles. So again, I know I've said start with the front side, and so I know that triangle looks like the front side, but since it's a base, I'm going to wait on that. So I'm going to say, let's start with, and again, it doesn't matter. You can start with any of these sides, so your net may look totally different. I'm going to start with this being in my front side. So that is, and it is 6 by, this side over here is the same as this, so 6 by 4. Okay, so I can do it this way. It's going to be a little bit different. I should have put that kind of sideways. Basically, for this one now, if you do a side on here, that's going to be the triangle side. That's on the 6. And so if you continue it this way, which I will, you're going to actually go upwards. So the next one is this side, and it is 4 by 10. And then the other one is on the other side is 4 by 8. And hooked onto that, we have the triangles. And so let's see the best way to do this. So this is 8 and 10. Same thing over here, 10 and 8. Because again, that's the dimensions of the triangle. I have 8, 10, and this side is 6. So that's why it goes to this side. Again, there's several other ways you can do this. Kind of hard to see. I don't know if they're right angles or not. Oh, they don't mark them as a right angle, but they definitely, these should be right angles. Sorry. Let me just write those that way. Because we're going to have to find the area of those, and that's going to help. So sorry, this is 8 and 10. 8, 10, and those are right angles. So, to find the area of those, this first one is 4 times 10 on top. Then we have 6 times 4. Then we have 8 times 4. Then both of the bases, we have 1/2 base times height. So 1/2, 6 times 8. And then same thing with the other triangle. So now all we do is add those together. 40 plus 24 plus 32 plus 24 plus 24 is 144. And that should be yards squared. Now I will say it's a little bit unique that we got 6 times 4 is 24, and the other two are 24. So I maybe made a mistake. If you want to go back and check your work, you can. But again, since I've already recorded this once, I'm going to say I maybe made a small math mistake somewhere. But overall, that's how you do it. You find the area of all those. Just make sure the two bases for this are triangles. So to find the area, it's 1/2 base times height. It's not just length times width. Next one, we have a trapezoid prism, or trapezoidal. So I am actually going to start with, so this is the base. So I would start, because I want to kind of make that look the same. And this is where a lot of people, some of you guys are going to be terrible. Some of you guys are really going to be good at this. And when I say terrible, I guess I should say some of you guys are going to need a lot of practice with this. Some of you guys, this is going to come really easily. It all depends on if you can visualize stuff. So for some of you guys that come into math, you say, I'm just really bad at math because I'm a really visual person. This is where you should be good. So if you say that, then you should be good at this. If you're not, then maybe that's not what your problem is. So I'm actually going to start with this bottom part here facing us, because that way I can put the base on top and bottom. So that bottom part goes here, and that is 3 by 6. because all these are 6. 3 by 6. So then we have this side. We're going to go over here is 6 by 4. And the other side over here is also 6 by 4, I believe. And then the bottom, excuse me, is this 6 by 7 rectangle. So this is still 6. It has been for all these. By 7. So then my trapezoids look like this, roughly. I mean, that's very sloppy. But this side is 3. That's how we started this. The longest side is 7. And then our slanted sides are 4 and 4. But we really don't even need to know that for this part because we don't use those slanted sides to find the area. So now find the surface area for this. So I have 6 times 7, 42. I'm just going left to right. 6 times 4 is 24. 6 times 3 is 18. And 6 times 4 is 24. Then we have 1/2 base 1 plus base 2 times the height. So we have 1/2 base 1 and 2 is 3 and 7. And then the height is what they give you right here is at 3.5. That's 1/2 10 times 3.5. 0.5 times 10 times 3.5 is 17.5. Now here's the thing. We talked about this at the very beginning when we talked about the definition of a prism. Sorry, let me see if I can find it. Oh, no, shouldn't have done this. It's going to take too long. The prism has 2 congruent and parallel bases. So since they're congruent bases, then if you find one of the bases, the other base has to be the exact same. So just make sure you remember that. Oops. So we found one base is 17.5, so the other base is also 17.5. So we add these together, 42, 24, 18, 24, 17.5, 17.5. So 42 plus 24 plus 18 plus 24 plus 17.5 plus 17.5 is 143. So this last one is a cylinder. The nets for these are easy. And the diameter is 14. And the height of this one is 8. So I told you this. I didn't think this was going to be on here, I guess, but it's here. Oh, well, they just give you the formula. All right, cool. So rather than, and again, you could have found this on our own. We could have found the area of this first circle is pi r squared. So it could have been pi times 7 squared. But then to find this one, to find this top length, it's the circumference of the circle. So you'd have to find the circumference. So that'd be 2 pi r, and then it'd be 8 times 2 pi r, so on and so forth. However, they just gave you the shortcut. They're giving you the formula here. So all we need to do is plug that in. So my h is 8 for this one, the height, and the r for this one is 7. So 2 times pi times 7 times the height plus 2 times pi times 7 squared. Now earlier we talked about leaving things in terms of pi. If you want to do that, you totally can. 2 times 7 times 8 is 112. So 112 pi plus 2 times 7 squared is 98 pi. If you add those together, that's 210. Pi, don't forget that, centimeters squared. So that's one way to do it, or you can always just use the decimal. So 2 times pi times 7 times 8 is 351.858. 4. Then 2 times pi times 7 squared is 307.8761. And then add those together. Is 659.73 centimeters squared. So if you have any questions, make sure you're asking. Again, eventually we will get into the formulas, kind of like what we just did with the cylinder, and it's just going to be knowing what to plug in. So hopefully it won't be too bad. Again, if you have any questions, make sure you're emailing me or asking.